Okay, the first question, use implicit differentiation to find the partial derivative of z by x and by y. Okay, first you're given an equation. The left-hand side is xyz is equal to cosine x plus y plus z. Okay, so here we assume that z is a function of x and y. Okay, we assume z is a function of x and y. Okay, so naturally we can get what is dz over dx. Okay, so the first thing you can do is you can differentiate both sides by x. Okay, if you do that after some calculation, you can get the answer. Okay, but here I can introduce another simpler method. Okay, so first let's just move the right hand side to the left hand side. So I get xyz minus cosine x plus y plus z is equal to 0. Okay, and I'll call this my fxyz. And I'll call this my fxyz. So actually, this fxyz, it is a function of x, y, and z. So all three variables are treated equally as inputs. Okay, no variable is a function of another variable. So your df over dx, it's going to be same as negative fx over fz. Okay, it's just a formula. So what is fx? You just have to differentiate this by x. So you treat yz as constant. So you differentiate this part, you get yz. And you differentiate this part. So first, cosine, you get negative sign, right? And combined with this extra negative sign, so it's plus sine x plus y plus z. Okay, over. Then you differentiate this part by z. Okay, you differentiate this by z, you treat xy as constant. So you differentiate this by z, you get xy. And you differentiate this by z again, cosine, its derivative is negative sine. So it's plus sine x plus y plus z. Okay, this is the first part. And then what is dz over dy? So similarly, dz over dy, it's going to be negative fy over fz. Okay, it's going to be negative fy over fz. So fy, you just differentiate this part by y. Okay, you differentiate this by y, you get xz, and you differentiate this by y, you get plus sine x plus y plus z. Okay, and the bottom, it's the same. It's xy, right, plus sine x plus y plus z. Okay, so that's the first two parts. For question 2, it's going to be very similar. Sorry, for question 1 part B, yz is equal to ln x plus z. Okay, so first you can move the right hand side to the left hand side, so it's yz minus ln x plus z is equal to 0. Okay, so you can treat this part as your f, x, y, and z. Okay, you can treat this as your f, x, y, and z. So now your dz over dx is negative fx over fz. Okay, what is fx? You differentiate this by x. You differentiate it by x, you treat yz as constant, so this part disappears. And then this part is going to be negative 1 over x plus z. Okay, that's fz. And over the bottom, it's fz. You differentiate this by z. You differentiate this by z, you get y. Right, and you differentiate this by z, you get negative 1 over x plus z. Okay, you get negative 1 over x plus z. Okay, So then you can simplify it by multiply both sides by x plus z. So the top is 1, the bottom is just y times x plus z minus 1. Okay. So the same thing, you can do dz over dy. It's going to be negative fy over fz. Okay, so negative z fz is the same. Okay, what about fy? You differentiate this by y, you just get z here, right? Okay, and also you can simplify it by multiply the top and the bottom by x plus z. Okay, so it's negative z x plus z. Bottom is y times x plus z minus 1. Okay, so that's the first question.